Hello and welcome to another episode of EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in sustainability, climate change, buildings, and urban efficiency. I'm Vic Marinich, Global Marketing Director for Danfoss, and I'm delighted to be the host of this podcast. You can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever you get your podcasts. Today, we have Paul Selking from Water Furnace on the show to talk about the Inflation Reduction Act and its implications on the commercial geothermal space. Paul is the Vice President of Commercial Sales and Marketing for Water Furnace, which manufactures and distributes geothermal and water source heating and cooling systems for residential and commercial buildings. Paul, it's an honor to have you on the show.
Thank you, Vic.
So maybe let's kind of talk a little bit about you here first. Can you tell our listeners about your background and how you got moved into the commercial geothermal space?
Yeah, I would love to. And we really appreciate being on the Danfoss podcast. I can tell you your team's doing a great job with these. I love some HVAC-centered podcasts. There's not a lot of them out there. So a little background on me, it a little bit parallels Danfoss from the perspective, my first 28 years were in the HVAC component business. Started with the GE with their ECM blower motors. And then more recently here, the last 3.5 years, I've been at Water Furnace. And, we take all those components from manufacturers like yourself and my former employers and put them together, right? We make solutions that we believe, bring heating and cooling to the world. And we use a couple of really common mediums for that. The good old ground and plain old water. And I'll obviously get a chance to share more of that throughout the podcast.
Great. So and maybe let's start there, right? Because today we're talking commercial geothermal heating and cooling systems and specifically how they may be impacted by some tax incentives from the Inflation Reduction Act. But let's start with the real basics here. And can you describe a geothermal system and how does it work and how it's different from what most people probably have whatever in their home or see in their office space?
Yeah, it's pretty easy, really, at the end of the day. I don't know if you're like me, if you've ever walked outside, Vic, and you got bare feet, right? And you walk out onto concrete, and it's kind of nighttime, but it's been a nice, warm, sunny day, right? Well, the concrete feels warm still, even though, maybe it's 50 degrees out, air temperature at this time. So, the ground, it's a great big heat sink, and we view it as a heat sink of renewable energy. And matter of fact, right, kind of to transfer that energy, we just say, okay, let's run water through standard everyday pipe and transfer the energy, right, between the building and the ground by using that water as a great mechanism to transfer that energy. So just, kind of basic thermodynamics. Ponds and lakes are also a really excellent resource for us. As I don't know if you're an ice fisherman or not, Vic, but after you go down just a little bit, right, it's back to water and you go a few feet deep in a pond and the temperature's stable there, just like the ground is stable a few feet down underneath the top. And it just stays at that same temperature. And we use that to heat and cool then year round, that very stable, either water or ground temperature, either one. So it's a pretty straightforward concept of kind of basic thermodynamics back in 6th, 7th grade. It was just called physics at that time, right? So you got into engineering school, then they added the fancier names to it. But so that's kind of how we start.
It sounds like we have a different heat sink maybe than what we're used to having in a heat pump or a chiller. Are there any other differences in the system itself between a geothermal system and a heat pump?
Yeah, you kind of touched on that a little bit there because the term heat pump, the good news is in the world we're in, the term is becoming very recognized, right? It was not as recognized in the very near past. Now it's very recognized. And usually when the term is used, you're speaking of an air source heat pump, and that exclusively uses the air as that sink, as you were just talking about. So those are great products, and they definitely are part of the electrification and decarb challenge that we're all faced with. However, they're not nearly as efficient. And the way that I would describe that to you, Vic, is to think of an ice cold cooler with, I'll call it your favorite beverage in it, and it's got a nice water bath in it. And you have to dig down into the bottom, right, through all the stuff that nobody else wants to drink to the ones that you like. So your hand's in there for 10 seconds in that cold water bath. but it's crazy cold, right? Even though it's just 10 seconds and you pull your hand out, but the water was just 33 degrees, right? It wasn't freezing because it wasn't ice. It was still liquid. Take that same arm, put it outside when it's just a 33-degree day out for 10 seconds. Sure, it feels cool, but your arm doesn't get frozen. It doesn't feel like it does, right, in that
Sure.
10 seconds,
Yep.
like the water. And
Right.
so, that's kind of the way to think about how much more efficient and how much thermal energy that water can transfer versus air.
Mhm.
So that's a way to think of the efficiency of geothermal over an air source heat pump. They're both heat pumps, just one uses air and the other uses water. So, you want to geek out a little bit, Vic, the way that,
That's what we're
a
here
lot of
for. Yeah.
the way that a lot of people like to talk is, EER, right? Energy
Yep.
efficiency ratio. So the difference there, you're going to find, 1 to 2x more efficiency in a water source or ground source heat pump. And if you want to talk on the heating side, right, people, COP are very popular now because we
Yep.
need to solve the heating challenge with decarb. So coefficient of performance for heating performance side, geothermal, you're going to get in a 4 to 5.5 COP. And for maybe those listeners aren't as familiar with that, an electric strip heat is just a COP of 1. It's 1.0. It's kind of the baseline. And an air source, you're going to be in like a 2.5 range.
Mhm.
So we're even more than double that. And that's really a great piece, right? We believe the lowest operating cost solution, and it's a renewable energy source, right? You're using
Right.
the earth. So those are some great items that really feed into why we do what we do and why we participate in this space.
Yeah, I think you nailed it there, Paul, that heat pumps are becoming almost, we won't quite call it an everyday term yet, but they really are gaining in popularity, right? It's not just at things like the HR show or whatever, a bunch of geeks here talking about them, but you see it on the nightly news that heat pumps are coming and electrification of heat and those kinds of things. So it really is becoming more and more mainstream. And geothermal then, right, is playing a big part there, as you mentioned, a lot more efficient than a typical air side. But is geothermal a good choice for everybody and anybody, or who's going to get the most benefits by looking at a geothermal system? And when would you really want to make sure that you're evaluating one?
Yeah, they are very adaptable. So that is one of the benefits relevant to who are they a good choice for. This business here that I get to participate with was founded and grew its brand on the benefits for residential homes. So that was kind of the choice and where they were applied in the company's history here. And I personally have had one in my house for 23 years now. So, right, it's a great solution for residential facilities. But to look more commercially, they're really good when you've got differentiated loads in a building. And think of like an educational building, Vic, where you have a set amount of occupants, so many students, let's say, for the most part in the day, but they're moving around, right? 1 hour they're in the lunchroom, then there's a bunch of them in the gym. However, the office area has always got people in it. It's more consistent, but yet to the whole load. So geothermal heat pumps, we move the hot and the cold water within the building to the right space conditioning requirements. And it's not just that, but in many cases, we don't even have to use the ground loop or the pond because we've got heating in one space, cold in the other. Well, the byproduct of a geothermal water source heat pump, when you're heating, is cold water, right? So then I can direct that cold water to where I need it for cooling. And the byproduct of the cooling side of the heat pump is warm water. So we'll talk about that as a net energy loop a lot of times within a building. The other thing that we see, to your question of who's it a choice for, who should be looking at it, post COVID, the office building utilization has changed. People come in at varied hours. I know some companies, you work 3 days a week in the office, 2 days from home. So similarly to the example with the education I gave, water source heat pumps, right, they're great for that because you can have a very large variation in space conditioning. And we like to use variable speed compressors, which are right up the alley of Danfoss, along with electronic expansion valves, because now I can take that unit and I can operate it at about 25% of the total capacity based on the load of my building. And the real benefit there is that now I'm not fast cycling. And so I'm maintaining a very steady operating window of the refrigeration circuit. and it's giving excellent comfort. So it's not that, oh gosh, I can't wait till the thermostat kicks on and it cycles real quick because it's way oversized. So sometimes people, I think, don't think that this industry has the technology applied, but it absolutely does have all of the latest technologies applied to it to provide the best thermal comfort also for the occupants.
That's a really interesting, important point you brought up there, Paul, about the ability to do heating and cooling at the same time, right? And shifting the load around the buildings and taking advantage of the excess heat or excess cooling, right? Because we know not everybody wants the building at the same temperature at the same time, depending where the people are. So, yeah, I think really important point there. So that's kind of on the inside of the building. Maybe if we look on the outside for geothermal, when should building owners consider looking at a geothermal system? Is it only really for new construction? Is it something that can be done retrofit, or does it depend, or how should we look at it in that regard?
Yeah, it's a good question, Vic. I think the way to think about it is to look from a life cycle cost perspective. It's so intriguing to me right now. And I know some of your past podcasts have touched on some great sustainability topics. So you hear companies talk about their commitment to ESG and sustainability, and then you drive past the building and you see the roof is littered with 8 to 10 SEER rooftop package units that are the most inefficient. But if you're going to go geothermal, clearly new construction becomes a much easier upfront installation because you don't have to work around the existing building infrastructure. However, you can still get a very nice upgrade in efficiency by retrofitting existing units to water source heat pumps and chillers. A great example is in Maryland, the Towson Courthouse. There, we had one of our rep partners that helped that building designer decarb that building by simply using heat recovery chiller. So what they're doing there is just trying to provide as much heating that is required by using some of the byproducts of the other units in their building that are already operating, and otherwise we're just exhausting either to the atmosphere or putting the energy back into the loop. So they did that, and they've seen like a 59% reduction in natural gas in October and November. And it went so well that Jay Sean was the engineer that did that. And he actually received your Envisioneer of the Year award in 2021 for that. I love that project because it just highlights, to your question, right, of new construction retrofit. And it didn't eliminate natural gas on that site, but it had a big step in decarb. And we all, I think, would agree that this is a journey we're all on to go down the decarb path. And it's not no carb out of the gate, right? It's trying to reduce that usage. And this is just a great example in an existing building where they were able to use some of these, I'll say, product solutions without having to redo the building totally, build it from the ground up or anything like that. So it's got applicability both, but definitely life cycle costing is a nice piece to consider because it's got such a low operating cost for the owner at the end of the day.
Mm-hmm. And then to make a plug on the Danfoss behalf, we've actually just released a white paper about all that energy that today is just given off as waste heat, and something that we should really focus on capturing and reutilizing that waste heat energy to do exactly the stuff that you guys did at the Towson Center.
Don't you love it when you drive by a facility like here in Indiana where it's cold outside and you see them putting all of that waste heat up into the air, right? And you're just like, no, somebody come grab it. Yeah.
Cooling towers running when it's 30 degrees out, right, to keep the chiller going. So maybe we can even put a link in the show notes to the white paper that Danfoss just published, because it really is just so smart and really basic when you think about it, to just reuse that heat somewhere else, right? Why just dump it to the atmosphere? When looking at the units themselves, right, our industry these days, we've got a lot of moving parts. And one of those moving parts is refrigerants. We see a lot of changes coming down the pike globally, right? It's not just a U.S. phenomenon. So we see a refrigerant transition coming away from HFCs, going to lower GWP refrigerants in 2024. How do you see that transition impacting the geothermal heating market?
Yeah, it's tied to a second one too, Vic. You've got that, and we're going to talk, I think, later about the Inflation Reduction Act. And there is a lot of connection there. The connection of both of those, though, to your question, I would classify as we see it as very sunny days ahead for geothermal systems. We like the sun, it heats up the earth, and we love that. So it is a positive influence on the overall adoption. Now, let's talk about specifically the phase down that you mentioned. So, water based heat pumps, as we described earlier, they have a very low factory sealed and tested charge in them. So the charge amount to begin with of the refrigerant that's used today is low to begin with. But then inside the building, we're using water to transfer the energy. That's the medium that we're using between zones that need cooling, maybe on a fall day that's got solar gain here on like my window to my left out on the perimeter, but inside, they're needing heat. So we don't have long line sets of refrigerant, even like you might have in your own home, right? If you've got an outdoor split system. So we don't have any of those with our units to an outdoor condenser or manifolded in the building. And that's a big benefit for water sourced equipment when you talk about the refrigerant change and the use of what will be then in the very near future here, the A2L refrigerants. So in general, it's always good to use less refrigerant. And we really are seeing MEPs and architects that are adopting that approach of how do I build and design a building with the lowest refrigerant footprint possible. And these products have always been that, being packaged and self-contained like that. They've been a great solution. This is kind of bringing a little more visibility to that benefit that's always been there. And that's a positive thing for us and for our industry.
Yeah, so the refrigerants are one battle you as the manufacturer will have to tackle. I think the other that's coming up in 2023, and that's the increased federal efficiency standards on heat pumps. So are geothermal heat pumps rated the same way as the traditional airside heat pumps, or do you have different ratings, and how has those increases in the efficiency requirements impacted the designs?
Yeah, so the good news for me personally is, as you get more years under your belt, Vic, you've now seen a few of these. You've gone through this cycle a couple times, right? And Water Furnace has, prior to my time here, has obviously gone through this. And their approach, and it'll be the same in this instance that's going on now, as you reference, is we're going to always try to be on that upper end of performance when it comes to just the base efficiency. We want to just exemplify the fact that we're a reliable, renewable energy kind of company. And in general, the improvements to these efficiency minimums are a positive, right? It's kind of high tide, in our view, rises all boats. And so some of the details seem sometimes, maybe though, to your question, they're not always congruent with maybe the way traditional air source units are measured, and the standards aren't identical. So then there is some discrepancies. But in general, our industry, we got a lot of really smart engineers across many companies, and they're heavily engaged, right? The Department of Energy, AHRI, ASHRAE, all of those industry bodies are working together with manufacturers like ourselves to make sure that the details of the standard that you're talking about, therein lies the challenge. It is the details of the test conditions and all that you have to make sure that are similar to create some even playing ground. So our products are currently and always have been on the water source heat pump side, AHRI certified. So we use the 13256 standard for those. Our water-cooled chillers, they're also AHRI certified under the 550 standard. So from a customer contractor perspective there, what they need to be aware of is just to make sure you're buying from companies that have that AHRI affiliation. And remember that in our case, they're all 100% electric. And when we're talking about energy efficiency and reducing CO2, these products have no CO2 emissions, which is a positive in some of the goals that both governments and companies are trying to meet moving forward. So there's challenges always with an efficiency standard increase, but I would just say that it's not something we haven't navigated before, and a lot of really smart industry advocates are all working together to ensure that it gets what's intended, which is, in fact, to improve the overall efficiency at the end of the day.
Yeah, and I think you also mentioned it was important that this time it seems industry and the governments were working a lot better and a lot closer together. For those of us old enough to remember the R22 to 410A changes, the 10 to 13 SEER changes on the residential side, it was I don't want to call it adversarial, right? But there were certainly more tension, let's say, in those discussions, whereas now it really does seem public and private sector are really kind of on the same page, pushing forward, working together, understanding each other. So as we increase the efficiency standards, it's being done well and reasonably and timing and all that stuff. So it feels at least moving a lot better in that direction. Part of that move, of course, then is what we really came here to talk about, and that's the Inflation Reduction Act, the IRA Act. It's a historic investment in energy efficient technologies. And maybe can you give a quick summary to the listeners for what some of those key provision and incentives are around HVAC systems and geothermal?
So now we're finally to the fun stuff, Vic. All
Yeah,
right.
we are.
So maybe just there's a lot here. So there's another podcast. So maybe we put on the books for later on.
Yeah.
So let me kind of give you the listeners think about maybe four pieces. So first is we've had a 10% tax credit for commercial geothermal that was fairly underutilized. It just wasn't enough to move the needle. So that 10% is now 30%. So that's kind of a big element. Plus, if you purchase from a domestic provider, you can add an additional 10 points or 10% that gets you to 40% credit on that entire geothermal system. So the loop in the ground, the piping, the equipment, right down to the diffusers blowing into the space. And I'll just remind everyone that I'm here in Fort Wayne, Indiana, and our engineering, design, development, testing, and every single unit that is in our product offering is built right here in Fort Wayne, Indiana. So qualify for that domestic element. So that's the first element. We can really get into more on that at another time. So the second item is very new, and that is that you no longer need to have a tax liability. So in other words, in the past, it was for, in essence, for-profit companies. So now state, local, not-for-profit companies are eligible for this same tax credit that I just mentioned as item one. And in their case, it will be a direct payment from the U.S. government because they're not sending a check for their taxes. So that's the second piece. The third piece is EPAC 179D is a tax deduction, not a credit, but a tax deduction that's also been around for quite some time. That's been in play. And now it's still there to provide tax benefits. It's always been about trying to incentivize the building designer and or owner to design buildings that outperform the ASHRAE 90.1 standard. And in the past, it's been $1.82 a square foot if you exceeded that standard by a certain amount. Well, as part of the IRA, that now increased to a max of $5 a square foot. So it's not just, this one is not specific to geothermal heat pumps. However, geothermal heat pumps do qualify for that maximum $5 a square foot benefit. So that's three. The fourth item then to just keep in mind relevant to the IRA is that these units are qualified or classified rather in the tax code as energy property. So as a result, they also qualify for accelerated depreciation. Instead of a 39-year schedule that any of the accounting geeks out there are familiar with, now you can do that on either an accelerated depreciation that has a bonus plan in the very first year or over a 5-year accelerated cycle. And that has some very nice financial benefits to it. So as far as kind of, as you think of those four elements and how they're kind of geared up, they're definitely started, the history of some of the geothermal tax credits were towards for-profit companies. But that's obviously changed in some of the recent work here that has happened with the IRA. And there's really a couple nonprofits, let's say in the case of a school, but there's a couple people that benefit in the case of a nonprofit, just to for folks to think about. The school district itself would get that 40% that I talked about, that first item, the 30 and the 10. But then, because they're not paying taxes, the MEP or the architect qualifies for that 179D, that $5 a square foot, because they have a tax liability and they can apply then that deduction of $5 a square foot to their tax liability. So they both can benefit, and it's encouraging, the designer, regardless if they're designing for a for-profit company or for a not-for-profit or a school. The other aspect that is still developing on this whole thing, Vic, is that there's some aspects in the IRA that we think will be beneficial for utilities to also be a part of the geothermal industry. And some of those details we're working out right now. We've got some of our team and others in the industry working with the U.S. Treasury on some of the definitions, because some of that doesn't come out right when these laws get passed. So the positive, though, that we believe that will drive is that it'll allow utilities to play in the spaces of doing what we would call district loops. So think of gas lines, right, that come to your house today. Well, instead of it being gas, it's just a water line, and it's connected to a large geothermal field. So those we think will be beneficial a little longer term to our industry, and they are outlined. There's just not, some of the definition is still being worked through the language, but those should have a very positive impact also from the IRA. We talk about some of the utility side too. So a lot to unpack. That was your Reader's Digest version for those people that are old enough to know what Reader's Digest is.
But it seems like the Inflation Reduction Act is really aiming at all the stakeholders. You mentioned the 30% or 40% credit that could go to the building owner, whether it's a school district or private property. You've got the reduction per square foot, which could go to the engineering firm working towards the design. And then you've got some incentives for the utilities. And that's always, I think, really important, right? If you get an owner wanting to do something, but the engineer and the contractor think it's a pain in the neck or don't want to do it or and all that stuff, and they're not motivated to do it, or the utility, they want to keep selling you gas and not convert you over to a heat pump or whatever, right? Then, right, you're
one
really
break in the chain is all it takes, right? And it's done.
Exactly. It just takes one person to kind of poo-poo the whole project and suddenly just kind of give up and go back with what you had. So I think that's really cool to note that took into account all those different stakeholders to kind of drive all this forward, whether it's geothermal specific or, as you said, there's some that are really just in general around improving efficiency. But then if we do talk to geothermal specifically, how do you see the geothermal market coming out from the Inflation Reduction Act, from the AIM Act? I mean, do you see this as a boost, relatively speaking, to geothermal? Are these acts really pushing more geothermal more than or ahead of some of the older existing technologies? Do you see this as a good opportunity for, let's say, building owners or other stakeholders to take that next look at geothermal? Maybe they looked at it some years ago, decided no for whatever reasons, and now's the time to kind of really reevaluate that.
Yeah, it's really important, I think, to kind of think of that question, to walk through the financials using all the benefits of the items that I talked about throughout this podcast that are now available. Because if you do that, you'd be hard pressed not to convince yourself that it's a very positive impact, and both financially and clearly, right, doing the right thing for the planet, which hopefully we're all trying to do every day. That's, I would say, our focus when we think about that question. We're working every day to support our customers with products and the services that align to their expectations. It's not so much, well, it's got to be geothermal, or what is the differences in a traditional system versus geothermal. It's kind of like, well, let's talk about the financial case, the life cycle cost. Let's talk about the positive impact that this system can make for you, for your company, on some of your goals that hopefully you're setting. And so that's what we're trying to do when it comes to trying to solve that question of how this affects them.
So if you're a stakeholder, and whether that's an engineering firm, a building owner, a contractor, what can they do to make sure they're taking full advantage of these opportunities that are out there, right? They're not going to be here forever. So who can they reach out to make sure that they're really getting every dollar that they can of these opportunities while they're available?
Yeah, the chain, as we talked earlier, right? Everybody's got to be in sync. And we said the IRA is kind of touching on all of those. And I think the way that they take advantage is great, because it's not automated, meaning just like people have to listen to this podcast to learn, I can't have a computer listen to it and I learn from that. I have to listen to this. And I think that's the great part, Vic, to answer your question, because our industry, we still transact with people, just like you and I are doing right now. It's people for people, right? Yeah, do we have remote diagnostic things, chat tools? Of course, right? Those are, you have to survive. But what's an architect doing in terms of your question of how do we get this to people? An architect is listening to the building owner And they're saying, okay, I'm going to design a space for you that's specific to your needs. And then what happens, right? An MEP takes that. He or she works then with an OEM to lay out the best mechanical system to meet what started that owner and architect. Well, what happens next now that they've got a mechanical system? Right now, a contractor gets involved. They're laying the pipe in the ground. They're wiring up the unit. They're programming it to operate what our building needs. And now, when people, again, step into this building, it's got an indoor environment that's healthy, it's fresh. It wasn't a software program that did that. It was people listening, working together to design it, build it. And now what do I have? It's energy efficient, it's environmentally friendly, it's comfortable, and it's still cost effective. Some of that as a result of the AIM Act and the IRA, clearly, right, from an incentive perspective. But how we bring these to people and deliver these results, to your question, our biggest opportunity is just to not lose sight of what is that voice of customer? What are they needing? And then let the chain of people work together to deliver the benefits that these systems can provide. They're not the only solution, but they're one of the, what we believe is the better solutions to provide all those benefits. So that's how we bring this to bear to the market, so to speak, is good old people listening to what the needs are and then using some intellectual knowledge to apply these systems in a way that delivers these great buildings that we all that are in the working world live and work in every day.
Mm-hmm. Yeah, imagine that, people doing business with people. Huh?
Yeah, it's clever, isn't it?
Yeah,
novel.
Yeah. Absolutely. So before I let you go, is there anything I forgot to ask you or that you want to mention before we end here today?
Again, just reiterate the appreciation that we have of working with the team at Danfoss and having the opportunity. I feel the topics that you have had in there and your other 40-some that are already posted out there are a little daunting to me, but I'm privileged to have the opportunity, and hopefully it's been enjoyable. And we probably can talk for another one on more of the details of the IRA, as there's a lot going on there, but it is, as you said, Vic, I do think that they've got all the right pieces of the chain motivated to make this a positive benefit for not just individuals, but also for the planet. And for that, we thank Danfoss for the opportunity.
Fantastic. Thanks, Paul. So that's it for this episode of EnVisioneering Exchange. I'd like to thank my guest, Paul Selking of Water Furnace, for joining us. Don't forget to subscribe to EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever you listen to podcasts. Lastly, if you enjoyed this episode, please don't forget to rate, review, and share it with your network. Thanks for listening, and talk to you next time.
This podcast is for information purposes only. The views, information, or opinions expressed during the EnVisioneering Exchange podcast series are solely those of the individuals involved and not necessarily represent those of Danfoss LLC and its employees. Danfoss LLC is not responsible and does not verify for accuracy any of the information contained in the podcast series available for listening on this site. This podcast series does not constitute professional advice or services. This podcast, including Danfoss LLC and the producers, disclaim responsibility from any possible adverse effects of information contained herein. Opinions of guests are their own, and Danfoss LLC in this podcast does not endorse or accept responsibility of statements made by guests. This podcast does not make any representations or warranties about the guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. This podcast is available for private, non-commercial use only. You may not edit, modify, or redistribute this podcast. The developers of the EnVisioneering Exchange podcast site assume no liability for any activities in connection with this podcast or for use of this podcast in connection with any other website, computer, or playing device.